All right. Good evening, everyone, and welcome to session 11 of I Write, I Research, part of our academic excellence series on research skills in practice. Tonight's topic is supercharging your exams preparation with AI. To take us through this session, I am pleased to introduce our future speaker, Lenge Joshua. So Lenge Joshua is a chemical and petroleum technology student here at the University of Jos with expertise in data engineering. He has mentored at HNG for 2 consecutive cohorts, guiding participants across quality assurance, data, and automation tracks. And he co-founded Haystats, a data and statistical consulting firm, alongside an agri-tech R&D venture. Right? So please join me in welcoming Lenge Joshua as he walks us through today's session. Please, sir, the stage is yours.
All right. Hello. Good evening, everyone. For those still yet to join, my name is Lenge D Joshua. Just like my dear friend here, Ben, has introduced, and I am pleased to uh, be on the stage here today as a presenter. Several other times, I have coordinated and hosted a couple of sessions, but it's a privilege that I'm back here today as a presenter with a very key topic that resonates with the times the University of Jos students currently find themselves, and not just University of Jos students alone, students from across other institutions in Nigeria. It's no news that the first semester draft timetable is out, and in about a month from this date moving forward, students would be sitting down for their second semester examinations. So in the past class and moving forward up until when we get done with examinations, the I research team has decided to, share with students, um, you know, tips on how to, make best of their time during this examination period. Our last class, which I hosted, we invited Israel to talk to us about strategies, and what it takes to read, write, and pass well. I will be sharing my entire screen. All right, just confirm if I see my screen.
Yes.
All right then. So, all right then. Good. Thank you very much. So, all right. So this is what I'm talking about today. Supercharging your exam preparations with artificial intelligence. It is no news that AI has become a dominant part of our lives. I recall in 2023, 2022, I think I was still an intern with HNG. I heard that, you know, there was an AI tool that has been released called ChatGPT, and everyone was surprised that ChatGPT can write code for you, execute code for you. So programmers then were very happy. So I first learned about an artificial intelligence tool that actually works during that time. I think that was 2023, I guess, no, 2022, 2023. 2023 to be certain, and that the product had reached 1 million, users registrations. That was very, very peak. And this day forward, we've had tons and tons and tons of tools, right? So something that has become very part of our lives. It's something that we need discussions with. And using AI with intention and not with dependency gives us the particular right mindset on how these tools are actually used and for what purpose and how they could actually serve us great purpose. We're talking about how to utilize them now in examinations. So, like I've said, my name is Lenge Joshua. and let's work with this class together. So the this class is structured into four pillars. The first is AI as a study tool. It involves the realistic expectations we have with AI capabilities and its limitations, and also its importance, and also the limitations tuned to the academic setting. The second pillar is noting to knowledge. Now, there's a tool called NotebookLM. It has a new name now called the Gemini Notebook. It's a tool that has been developed by Google. It helps you put together several sources, up to 50 for those who are on Pro. And it helps you put together all the sources, helps you organize, helps you summarize, and it also helps you to query and discuss with your material. And then we've also got Claude for deeper insight. So Claude is an AI chatbot or an AI tool. I think Claude is too big to be called an AI chatbot, although it is. It's a tool that was developed by Anthropic. So Anthropic is an American company that produces these chat tools, these AI tools, which is very, very powerful too as well. So instead of just utilizing Claude, Claude is too powerful enough to not utilize it for something very important. So that's why we are integrating Claude in this class with Notebook LLM to help us quickly solve problems. We've heard about the Fable 5 that can solve very, very well complex problems. So utilize how we're going to poke into the power of Claude today. And then the last pillar is without losing learning. How can we utilize these AI tools without feeling guilty or without feeling the fact that we've outsourced a critical part of our thinking and cognitive show to artificial intelligence? So we discuss these four pillars in this class moving forward. So AI is a study tool. We'll be looking at some realistic expectations about its capabilities and limitations in academic setting. And I have the data here. So whenever I do things, I always like to fetch from facts, and not just facts alone, facts that are data backed. And to actually set this stage, it's very crucial that everybody understands that AI adoption is no longer a fringe activity. It's, I'll call it the new academic baseline, right? I've seen schools that have paid these companies hundreds and hundreds of millions of dollars to enable students in their campuses access these chat tools. And universities and colleges, I wanted to see how these people are using AI, right? And you could see here that 90% of university and college students use AI in class at least occasionally. 90%. And 86% of students globally use AI in their studies. This data was gotten from the Digital Education Council. And 54% use AI on a daily basis or weekly basis. So these numbers are more far way wider than the average. And if we're talking about the high school, 84% of high school students, that is, high school is the level at which we have secondary schools here in Nigeria. 84% of these students use generative AI tools for their schoolwork, and 46% of those high schoolers rely solemnly on AI for their college, search processes. So it gives us the idea that adoption is rapidly increasing at rate among, younger students, and the baseline is just always rising. This is just we're still struggling with whether or not we should accept AI fully in education or not, right? So this nuances doesn't get, tuned. It gets further interesting over and over. So, like I said, I wanted to understand. So, the purpose of this preliminary search, like we have seen, how widespread AI really is, was for me to understand moving forward how people are actually using these tools. This is generalized data that gives us the thresholds of a group of people within a particular set, that is level and then the high school level. We just saw the numbers on the general level, but then we want to dig deeper to understand the common use cases and how they help address, where students may be, having realistic expectations. So, what are students actually using AI for? Understanding common use cases helps us address where students might be forming, having myth, or having those unrealistic expectations. So, from the data, it says that 69% of university students use AI primarily for search information. That is for information search, retrieval, and research. and 51% of students and early career researchers actually use it specifically for literature reviews. So this ranking was done. After getting this data, a ranking was done to actually see where the most part of the numbers actually lie. So it's no news that we've also heard rumors that ChatGPT had intentions of acquiring Chrome, because a lot of people no longer do the traditional way of searching things, that is going to Google and typing search prompts and some of those search queries. People now rely on chat tools to search for stuff, and that's what this data tells us. And as you can see here, 69% is way above 50 and 50 way above 42. So this is how the ranking goes. So on the second rank, how people actually are using AI for ideation and brainstorming, it says that 50%, or I would just say half. So given the population in University of Jos, right, if on the I don't know the population of University of Jos students currently, but I think if we're up to like 50,000, then by this data it says that 50%, that is 25,000 students, are actually using AI for ideation and brainstorming. And then 42% are actually using it to edit grammars. That is, those who are doing literature review, those ones who write letters, to their pros, those ones write letters to their girlfriends, those write letters to several use cases. 42% of them are using this chat tools, right, for editing their documents and also for grammatical corrections and all. And then the fourth ranking is for summarization and paraphrasing. So 30% of students use AI to summarize dense documents. 28 of them use it to paraphrase existing document. You may have heard some students during the examinations. Some people would say, I am moving at 6 or 7 pages per second. What these people are actually using is, how can I use AI to summarize maybe 50 pages of notes that I have in one semester, or maybe 25 pages of notes. So what AI does is just go through your note on your behalf, read those notes, summarize the notes for you, or paraphrase in best case scenario. So you can see a summary can cover 2 pages, and you read the summaries, understand them very well. I mean, you're good to go. So 30% of the students use summarization, use AI for summarization and paraphrasing. So that's actually how this numbers is passed. But then again, we're still having troubles with the wider acceptance of AI, and it's because of this particular modes we have. A lot of people have had myth about AI and also misconceptions too as well alongside it. So we cannot really understand the proper use cases of AI without understanding the difference between these two. That is the myth people have and misconceptions. So I just for us to bolster our idea about some of these two, I just gave a definition here. So a myth is a traditional story or a widely held false belief passed around until it is simply debunked. So I think yesterday I was having a discussion with Ben and a couple of other students in the lab. And we're talking about some of these particular stereotypes. So a myth, I think it's an, or should I say it's a stereotype now? Because if you look at it, it's a traditional story that you can't even validate. And also, it is also a false belief that is widely held by people, not just in that region, but other regions, about the particular group of people I'm not going to mention on this call, right? So that's what the myth is. And the misconception is a wrong idea that is based on people's failure to understand, right? So that's just what the misconception is. While a myth is an old traditional story that is widely or a widely held false belief. So these are the two things. So a lot of people have been divided across these divides between the myth and then the definition of misconception. So, like I have here on my notes, AI can be incredibly powerful study partner, but it is a tool and not a replacement for your own brain. Because a lot of people today have outsourced their entire thinking faculty to these chat tools. But then, how do you get the best of yourself without saying AI does the most part of it for me, and then I don't get to do something on my own behalf? So to get the most of AI without hurting your own grades in school, it is important to clear up a few common myths and misconceptions right from the start as we move forward. So the first myth is that AI is a fact machine. And the misconception around this myth is that students assume that AI always provides accurate facts, dates, formulas, and all sorts. But the reality is that AI is just a language model that has been trained on data. right? And it's not the search database that queries real-time live sources. So AI mostly it has or it lacks the ability, right, to sound generic or to have this human, intuitive motion in it. So the reality is that AI is a language model. It predicts most likely the next word from its training data. There's something we call vector search. So vector search, well, what it does is that it flattens the data, vectorizes it, and then it tends to like search what is it converts all of those things to numbers and then tries to find what is the next common word that's most likely to this current search, and then it pulls some of these words together. So that's how some of this search works, right? So it predicts the next most likely word, which means it can hallucinate. That's one of the very big problems of AI. So AI is never a fact machine because sometimes, especially ChatGPT, sometimes ChatGPT hallucinates. Sometimes if it doesn't know, it hallucination means that it could just come up with something that is not entirely true and give you as a fact. And because people have this, sense of reason that AI is always right, they don't check some of these things, they don't validate these things. And then you end up finding that AI has given you something that is beautiful and then non-existent, right? So AI could give you fake sources, AI could give you incorrect math formulas or false historical facts about your search. So that's the first myth. So this myth is actually very true as well. The second myth is that AI understands the material. That's a myth. Most of the times, AI understands your material, but not fully, right? You are the student who knows everything about your material, but then it's a misconception. So, around under the myth, people are still having misconceptions about it again. But the reality is that AI matches patterns in data. AI cannot critically think for you on your behalf or have genuine understanding of the material you've given it. It can only feed back the logic that has it has read from its vectorized data back to you, right? Sometimes it can be flawed, sometimes it may not be flawed, right? So the third and the fourth means that AI can do the learning for you, which is not true. Although AI can facilitate your learning, but learning requires cognitive struggle, like I've mentioned in the start. And when you outsource your hard work to these chat models, it can help you summarize, can help you synthesize your document in the best ways it can. But your brain misses out on the critical struggle that it takes to understand these things, right? What learning actually is that the neurons in your brain get sparked by the ideation and the concepts of the things you're reading. And then that's where cognitive struggle comes in. It brightens your mind. So if AI does everything on your behalf, you've missed out on this critical part. And AI output is ready to turn in. So students think that AI generated text is a finished product and it just needs just a few proofread and you're good to go. But most of the times, if you have read an AI generated text, going through, you discover that it's a very big, beautiful nonsense. Because sometimes some things just saying doesn't just make sense, but the work looks so very beautiful. Someone submitted an AI generated work and it was so terrible because someone who knows what they're doing would understand that AI, like I said in the beginning, AI writing is often too generic, it's repetitive, it lacks a unique human voice. That's how you read something that someone has written by himself, and then when you go through, you discover that someone actually with emotions wrote this document. So academic institutions, we're discussing with Ben earlier, some past few days, and we're talking about how academic tools that some companies have bells to proofread or fact-checked documents. And some of these tools sometimes often fail because people are getting too good in the age of AI because a lot of times people accuse you for using AI when you actually use your own cognitive struggle and cognitive, faculty of thinking to do things, right? So the May 5 is that AI knows the specific course context. If I'm attending classes twice a week for the next 3 months, AI can never know the full context of that particular course more than I do, although it has a very wide knowledge base. But I don't expect AI to know everything. I must feed in contexts to AI. So the reality is that AI has no access to the specific classroom lectures. You must provide those grading rubrics, provide those notes, personal reference, and all to enable AI facilitate the courses you are giving it to help you understand. So these are some of the myths around AI. So now the misconceptions. that people have about AI is what we're about to looking at now. So the first misconception is that AI is an infallible source of truth. Now, here's the reason: 65% of both college educators and student expresses concerns that AI can sound highly confident, and even when it is completely incorrect. I stated this in the past myth that people had, and this is the same thing. As you can see, this number is more than average, which means that people's misconceptions somehow are true, right? And then 62% of high schoolers um, who use AI have successfully identified errors, right? Or incorrect information in responses. This is true, right? So the takeaway from this is that um, AI is just a starting point, and it is not definitive source of truth. It hallucinates along the way. So students must verify that the outputs they get from these AI tools are confidently, you know, fact checked. So confident sounding errors are the single biggest source of truth risks in academic AI usage. And even students that are already catching them have explained critically their fears, right? Moving forward, like someone saying, I presented the work to my prof, I could not defend it in the best ways I can, so he thinks I've used AI. You know, people are feared and scared that their reputations could be ruined because they cannot explain a particular point they have written on their documents, right? So this is the second point now, or the second misconception that AI replaces the need for deep learning. As you can see here on my screen, this is from a student speaking on a recent panel. He said, if I can't explain my work to my professor without AI's help, then I didn't actually learn it. Like again, the data says 65% of educators and students share a fear that over reliance on AI would cause a severe loss in critical thinking and deep learning capability, which I think is true because these are valid concerns, right? AI can never and would never replace your learning. Something that you took time to study, something that you had cognitive struggle with, is different from AI just feeding you sources back, right? So the takeaway from this is that explaining your work unaided is a real mastery. If you can write a document with the aid of AI and can explain that document, explain every part of it, it's big. It's one of the big moves that you can take out of it, right? And one of the misconception is that AI is just an automated shortcut. And from the data, it says that most successful students don't use it or don't see it that way. Most successful students view AI as not just a shortcut to bypass work, but as a thinking companion or a co-supervisor. In one of the the lessons in this presentation moving forward, you would see is that it says, how do you utilize AI without you know feeling lost out? Because most of the times I feel being robbed whenever AI does things for me and without my own struggle in it. Right? I feel lost. And I've actually seen how people use AI, and then it surprises me. I'm like, how is this different from outsourcing your entire thinking capability and faculty to AI? Right? AI can be an incredible study partner as long as you keep it within the co-pilot seat. You write the pilot, AI co-pilots, you're learning alongside you. What AI should actually be used for? AI should be used to overcome the friction of the blank page syndrome. So the blank page syndrome is an instance where after using AI to study, you want to test your thinking faculty to validate whether or not you have actually invested some cognitive struggles. It says that if you cannot actually by yourself just write a few statements of the things you've read, then you don't actually understand what you've just done using AI. So that's one of the tests, the blank page, test that people normally do. So there's a syndrome that comes with it, right? Or challenge your assumptions or test the logic. So these are things that AI should actually help you do. So now, this most of my classes are hands-on in the sense that you don't actually participate in these classes without just seeing how things work realistically, because you may continue pondering on some of these theoretical concepts without actually showing how they work, then people don't actually get it, right? So we'll look at notebook LLM. If you don't have it, you can download it, but if you don't have it on your phone, you can just actually pay attention so you see how things work. So We're going to leverage Notebook LLM to efficiently summarize and organize and query our course materials, right? So I will go over to practical session. So let me go to, so I have a couple of them here. So this is how Notebook LLM looks like. So Notebook LLM is a tool from Google. It was renamed from Notebook LLM to Gemini Notebook. It is incredibly powerful. It is incredibly powerful. It's powered by Gemini 3.5 on a secured Google Cloud's infrastructure. And Notebook LLM again, it's arguably one of the most powerful tools that students can actually rely on because it solves one of the biggest problems we have with AI today in academia, which is hallucination. So what the LLM does is that it doesn't actually goes outside of the contexts or the resources that you provided. Couple of fact that it is multimodal in the sense that it accepts different kinds of resources. It could be text, it could be presentations in PPT, it could be docx, it could be videos, it could be YouTube links, and it can accept and synthesize up to 50 different resources. Right, that's what multimodal means. So if you look at the core concept of Notebook LLM, it is a closed loop. And what do I mean by a closed loop? Let me go back to my slides. I was on the slideshow. All right. So it is a closed loop assistant, right? Like I said, it is source grounded. That is, it acts as a closed loop research assistant that only pulls answers from the exact sources you have provided and uploaded, right? So it doesn't go. So it can actually go search online to reference not outside of the sources you provided, and then it actually provides you inline citations of your sources. So we'll quickly look at um NotebookLM from scratch. So this is what NotebookLM is. So you can actually click on create new NotebookLM. So each of so the Notebook LLM, it provides you so many powerful things. So let me just go back to this. Let me just go back to the homepage. So this how it looks like, right? You can actually come here and look at all notebooks, but going to the most important of our class, um there's something called every notebook. So you create different notebooks. You don't create different notebooks with so many sources in tune together. So you create a new notebook that discusses a particular section of a topic. So you can actually create a notebook that discusses, say, maybe algorithms with AI, or maybe discusses calculus one, but you don't mix your sources together, right? So like I said the other time, you can actually add sources. As you can see here, I can upload files, different files that I wish. I can actually add websites, links of websites, YouTube links. I can actually add documents from my drive, um, add sources here. I can actually copy text. I can actually copy a text and paste it here. I don't know if I have any text. All right, there's none. So, um, so that's actually how NotebookLM works in terms of addition of sources. And then here it as well, it has three major sections. It has the sources sections, and then it has the chart sections, and then it has the series sections. So we can see here that you can actually add sources by just searching, right? So we have let me use Chem 101 for example, or Physics 101. Students who want to read their sources for that session. Maybe I could just say, help me search, help me search for unit just ask questions um, on physics 101 and definitive guide on, on how to pass the examinations. So I can actually make a search. So this is the web search. I can search from the web or I can search from my drive. And then it also has this search here. You can actually do a quick search or a deep research. So a fast, I'm going to do a deep search, a fast search, sorry. And then I'm going actually search from the web. So I'm just going to click on this. So it's going to, research the website for this particular context. It doesn't give you any like sources that are outside of the things you provided. So as you can see here, it has found 100 level physics 101 materials. If I like the sources, I'm going to import them, right? So it's importing all of my sources because that's how it works. So NotebookLM is source grounded. It's the things you provide for it, it's the resources you provide to it that it uses. And so those sources are still loading. And then what is the input strategy? So how do you feed this AI? NotebookLM is mostly efficient and effective when a notebook is tightly focused on a single course, like I've said, or a specific exam unit or a major paper. So you don't crowd a single notebook with different things on maybe AI, mathematics, calculus, chemistry, physics. It doesn't work that way. You're not going to get the best of what you want. So if you want to discuss chemistry, and in chemistry, you want to discuss mass numbers, create a notebook for mass numbers alone, right? And like I said the other time, that it is multimodal. It has multimodal ingestion capabilities. That is, it can accept up to 50 different sources. You can upload PDFs, upload Google documents, website URLs, audio messages, YouTube lecture links, and so much, right? So it's big. So let me see. Let me go back to Notebook LM to see if these sources are finished. Oh, yeah, they're done. So as you can see, it just summarized all the sources for me: university academic guides and physics exam solutions. So there's just a brief summary. These sources provide a comprehensive collection of academic materials centered on University of Abuja and the University of Jos in Nigeria. These include past question papers from 2016 to 2019. So it goes on and on to tell you about the sources it has gathered information from, right? So if you like this particular note it has centered here, you could just pin it, because sometimes some of the things are temporary, right? And also these are suggestions. Now, as a student, if you want to query some of these sources, and then you don't actually know some of the questions to ask this AI, or to ask, yeah, this is an AI chatbot, or it's a RAG based. RAG is retrieval augmented generation. That is, it's the technology it uses to search your sources to ensure that it does not go outside of the sources you provided. Right. So I like to, ask about this. What are universal jobs by chemistry graduation requirements and dress code? This is not entirely, these are just suggestions, but it's not tuned to the things that I'm needing right now. So there's another suggestion here that says, how do the Bernoulli's principle and continuity theorem affect field dynamics? So this is just a suggestion. So I've clicked on it because I think it interests me to know, right? So as you can see, it is analyzing the fluid dynamics, revising the continuum theory, and goes on and on. So it has provided me an answer. I can actually close these panes. So it says the Bernoulli principle states that in a streamlined fluid theory, an increase in the fluid speed occurs alongside a decrease in pressure or potential energy. So, like I said the other time, it provides you inline citations. It can point you to where it actually sourced that particular section of this of the definition from. Like I said, it does not go outside of the sources you are provided, right? So this is the source. So I can actually click on view source, and I can go directly to where. So this is the source, and the source is actually a YouTube link. Funny enough, so I can actually skip the ad. So all right, so as you can see, 2026 sure examinations. So it was able to reference me this particular definition from this particular source, and this particular source is a YouTube link, right? So you can see how these things are. You can actually view the source. So it doesn't go outside of the things you provided. So this is another source here. I can actually click on view source, and then here's it, right? It's text. It's text. These are different past questions from University of Abuja. So that's actually what this does, right? So also on Notebook LLM, it's very, very, very powerful. Let me just give us an intro on some of the things here. So there's one very important thing about NotebookLM. The first I'd like to talk about is the mind map. So the mind map gives you a graphical interface of how some of these materials are to be structured. So it's generating your mind map. It's going to show you, okay, if I want to really study these materials, how do I go about it, right? Because you have just put together sources you believe your conviction points you towards to study for your examinations. But then, how do I actually go about studying these resources? That's what the mind map helps you. So it, it has generated the mind map. So we can see what the mind map really likes. So we have 10 sources just from a single web search. So first it says academic resources and course curriculum, right? And then it sectored all of these sources into physics, mechanics, and matter, mathematical geometry, biochemistry, rest of just academics, success strategies. So I should be interested in seeing what physics, what the mechanics and matters of physics are. And then I can come here, talk about the Kepler's law, and then under the Kepler's law, you'd see learn things like laws of orbits, laws of areas, laws of periods. If I'm interested in either of them, I can actually click on it. As you can see here, it says discuss what these sources say about the laws of areas in larger context of Kepler's laws. Pointing back to Kepler's laws here. So it goes on and on. It's going to explain everything. It can actually show you stuff on dynamics too as well. And then you go on and on. The map, expands itself. So if you shrink this map, you discover that it has helped you, you know, arrange your studies, right? If I'm actually going to study this, how am I really going to do it or go about it, right? So as you can see, so if I really want to study the mathematics and geometry of this course curriculum, I'm just going to click on it, and then you could see you could study the coordinate geometry if you wish or trigonometry. A lot of students within the basic level find struggles with trigonometry, especially when calculus is involved, right? And we are taught trigonometric identities, right? It's very, very interesting. Radians and degree conversion, acute angle ratios. So you could actually, let me expand this. Let me take it back a bit. Um, all right then. So as you can see, it says what does this sources say about trigonometric ratios identities in the larger context of trigonometry. So this is what they had to say. The sources indicate that in the larger context of trigonometry, the subject is taught as both foundational mathematics component and a dedicated university course. I think we did this in Maths 201, right? So this is it. It tells you trigonometry is a bit tricky. It's very, very fine cognitive struggle to understand. So that's what the mind map actually is. It helps you arrange and discuss, you know, uh, go about the discussion of your sources in ways that it's very structured for your understanding. And then outside the mind maps, you have, let me see what my slide says next. So let me put it a bit expanding. So the mind map, it automatically generates you visual interactive mind maps of course materials. Click different models to reveal the AI generated summaries. We've seen what the mind map actually is. And then we have the smart flashcards. So flashcards are just like there's a game where people actually show you like some of these small cards or small piece of papers where someone writes something, and then within 5 or 10 seconds you're expected to see the answer, right? So that's what some of these flashcards are. So you can also generate them directly on the source materials. So let me go back there to my notebook LLM and click on flashcards. So you'll see here generating flashcards. But also, right, many students don't have access to laptops, right? So this actually, it's not actually a barrier actually, right? If you don't have access to a laptop, I could actually show you how to utilize these tools um, from your phone, how to access and use NotebookLM from your phone. So I was able to do something with my phone. So I'm actually going to cast my screen. Okay, yeah, I'm not casting my screen, my phone screen. And let me let me expand this. So I'm casting my phone screen now. I'm gonna click on NotebookLM. So this is the app here. If you don't have it, you could actually download it. All right, so this is it. Right. So prior to this class, these are some of the things. So this is what we're talking about just recently. It's still loading. The chat we're having conversations with. All right, this is it 12 minutes ago. University academic guides and physics. So this was the question I asked on the recommendation of the mind map on trigonometry. Right. So this is it here. So this is what it looks like. So you can actually click it to view your sources. So these are all the sources that are present. I can actually add the source as well. So if I have something, if I have a text, maybe I can just type whatever the text is here. I can just actually type it. I could just say like Newton's law V uh one of V equal to U plus AT. And I actually add this as a source, right? You can actually use your cam so your camera, right? To screenshot anything. It's a source, right? Anything, any data. There's no data that's not important. So let me go back. And then you can actually come to your studio, like I've said, new short video over point, try it here as well. So you can actually generate an audio for your text. So I can actually click here. So if I want, so the video can be short, or the video can be medium, or the video can be long. It's dependent on me, and I can actually click on my sources. If I can also want to choose sources that should appear on that video. If I don't want any sources to appear at all, I'm just going to click on this. If I want things from, maybe I don't want sources from Scribe, I can actually unselect it. But if I want all the sources to be involved in creating me this audio, and I want it to be a very short one, and then the sources are much, right? The sub mind maps modules are much. So I maybe I just want this audio to be scaled down to maybe discussing. Maybe, let me just see discourse or focus your discussion. Focus your discussion um, on trigonometry. Or yeah, let me just say trigonometry, and then the language, which is if you listen to Espanol, which is French, it's a different. Well, I'm an English student anyway. I click on generate. I'll get a notification when it's ready. Yes, notify me. So I wanted this to be both sides. So we see how things are on the PC and then see how things are from students' perspective, because most students don't have laptops, right? So moving forward, most of this class would be practicalized on both ends. So we see, so it shows me generating here. So those flashcards that I wanted to generate then, um, it's done generating the flashcards. So we could see how those flashcards looks like. It's still loading. So according to the Kepler's first law, what is the geometric shape of the satellite orbit around the primary body? So these are, as you can see here, these are 1 over 65. So this is the first question in 65. So after studying, it is advised that you use flashcards to test your knowledge if actually you've learned something, right? So I don't know the answer. I'm going to click on see answer. Oh, the answer is an ellipse, right? I'm going to click back. So according to Kepler's first law, what is the geometric shape of the satellite orbit around its primary body? The answer is it's an ellipse. And sometimes when you're studying, you have to be sincerely honest with yourself. Because I didn't know the answer and I had to check, I'm going to click on this. You'll get it next time. So in the SI system, what specific unit is used to measure the quantity of substance? In the SI system, what specific unit is used to measure the quantity of substance? Now, the quantity can be volume, the quantity can be solid material. If it's volume, you can actually use mils, milliliters. can actually use liters. You can actually use percentage to measure volume. You can actually use yeah, pretty much it. If it's a solid material, you can actually use grams, kg, um what do you call it again? Like volumes, you can actually use dm cube, cm cube. You can actually use cubic feet to measure um mass materials. So let's see what the answer is actually. Mole. Interesting. What specific unit is used to measure the quantity of substance? Yeah, really mole. I was right, but I got it wrong. I'll be honest. Right, and then you move forward. It indicates. Okay, I'm coming. Let me see. What's the question? Is what is the physical significance of the negative sign in the acceleration during uniform retardation? It means that it's negative acceleration, indicating that the velocity of the body is decreasing over time. Yeah, so that's what negative acceleration is. I got it right. So you can actually go on and on with the flashcard. So the flashcard actually is like it sparks the neurons in your head, right? And it connects that cognitive struggle you've had in studies. So that's just what flashcards do for you. You can actually, if you're confident enough that you've read and you want to battle with yourself, you can actually click on the quiz. So you could see it's generating the quiz for me. Anyways, the audio is still generating itself, right? So these are just some of the few things around some of our sources. But then we would practicalize, so we've actually seen how some of things work. I'm going to create a new chat again. I'm going to create a new notebook, sorry. But then before I do that, so we've seen flashcards and we've seen okay, we've not heard, well, yeah, we've not heard what the audio looks like. That is the interactive audio overview. So it turns your dense reading into a conversational podcast. The student can pause. Funny enough, you can pause the podcast. It's not funny. Type a question about a confusing concept and get an answer. And it just baffles me how AI does this. So you could just actually type, you know, um, a misconception you're having about what is being discussed, and then the person in the podcast will just say, "Oh, I get a question," but it's just AI. So okay, so let me go back to my phone screen. So as you can see here, the trigonometry 5 minutes audio is done. I'll actually click on it. So this is what it looks like on my phone. I'm using my phone most of the time because most students use their phones for these things, right? So I'm gonna click on play. Let me increase the volume.
Car as you turn a corner. Yeah, or dictating the arc of a thrown baseball. Exactly. And the stability of the floor beneath your feet. So today we're taking a deep dive into the academic sources you shared. We've got math exams, physics tutorials, and we're trying to decode that fairy matrix. We are looking at trigonometry. Right, and we're going to try to strip away the intimidating chalkboard equations. Because, well, what we see in these sources is this beautiful transition from abstract puzzles into the exact math that governs the physical world. So let's start with the fundamental language of this code, which is angles. I noticed the material spent a lot of time on converting radians to degrees.
Yeah, I mean, so I don't know. Can you guys hear me? If you're following, this on mute and confirm.
Yeah, Dr. Hendricks. Can hear you clearly.
All right, very good. So, did you hear the audio that was generated from the app NotebookLM?
Of course, yes, I clearly heard that. It sounds so interesting how that the voices are between a male and a female, and it's more of like conversation between two persons who are discussing. And I'm like, wow,
Absolutely,
this is good.
it's interesting. So yeah, I mean, these are the power of tools, right? You have all of these things at your disposal, and most of the time you access them. It doesn't cost you much. In fact, it costs you nothing to access some of these basic things, right? And so you could actually, um, most times we as students who maybe in a chemistry class, I recall my first semester we had many chemistry lecturers, about three, take us on analytical methods, The other took us on, sampling. The other took us on, also some parts of analytic methods, right? Electrochemistry. So you have three different topics under one course itself. So how do you go about them? So NotebookLM has the capacity for cross-document synthesis, right? So you could actually upload those different source materials, lecture notes, and materials from different lecturers, and then it can help you synthesize arguments from all the papers. Let's I'm going to use my PC for this. So let me go back. So I created a new chat, right? So I would upload some of these materials from my drive now. So I'll go back. So we have what we call the SLT drive folder. Let me go to share with me, and let me try uploading some of these materials. Where did I keep this? Start. All right, sit here. So I'm going to go back to 400 level first semester. Chem 14 years. It is this course. So these are all different materials. It's all different materials. I'm going to upload all of them. I'm going to upload all of these materials. NotebookLM has the capacity to ingest up to 40 of these course materials. I'm going to upload all of them to see how some of these cross-document synthesis work like. So I'm going to insert all of these materials. So it's uploading all of them. So while it still loads, our sources is still loading. Yeah, it takes time to load some of these sources. We're gonna get there anyway. Okay, so it's done. So it's still gonna summarize what it thinks the best title of this, and it's gonna give it that title it by itself. Very good. Electrochemical and instrument methods of analytical chemistry. Very good. So I'm going to close this pane like we've seen. I'm actually going to say, I'll use the deep search now. The other time I used the fast search. I'm also going to use the deep search. I'm going to say, let me on this slide. Struggle like to this search. So I would say, okay, look at the sources. Look at the sources I've added. Look at the sources I've added. I have added and add more valuable ones you can find. You can find online that are tuned. What I have. All right. So this just ones I intend to write once. So I'm gonna click on this. It's gonna carry out. It's gonna map out a plan on how it intends to go about finding the sources. I'm actually just gonna like close this pane while it does the search. Right. So these documents provide a comprehensive foundation of analytical chemistry, focusing on the methodologies that are used to identify and quantify chemical substances, the material details, the management of experimental errors, distribution between systematic and random variations, while explaining how to calculate accuracy and precision. It goes on and on and on. So these are different suggestions from the material, right? That actually just spike your, intuition on some of the questions to ask. So we've seen how to upload some of this. So these are all the courses that make up our syllable, right? So I would give a prompt that tends to like, make this particular, Gemini model that powers this entire rack platform, Gemini notebook. I'm gonna make it to go to almost all the sources that I've uploaded that contain some of these search contexts, and then it's gonna compare and then it's going to explain me some misconceptions versus what is in the document versus what's in the other document, and then puts me together some of these thoughts. Because when you're writing examinations, you read all the sources together. So what some of these lecturers tend to do is that, okay, we give you all of these materials, different lecturers have taken you. We want to test your synthetic knowledge. How can you synthesize some of it? And how can you, put together thoughts, right, from this to make a very good answer of it, right? So I just entered some of these suggestions that says how the systematic and random errors differ in measurements. You can be asked this question in a way that it makes sense or it does not make sense, but then it doesn't change the fact that you must answer it in the examinations. Like I said, these are the inline citations, and you click on it to view the source where the actual that document. You can click on it and then view the actual document itself. The second type is over. All right, so this is here, right? B comment. Oh yeah, it's still writing me. It's writing the report now. It's almost done. So it's gonna notify me when it's done. So I would say compare the so I want to compare because there are theoretical, methods that back some of these instrumental methods against the actual, core procedures of how these methods actually instruments actually operate they themselves, and how to manage the errors, because we also talked about errors, precision, accuracy. So the AI would, read those documents, synthesize, its response, and then let's see what it has. So compare the theoretical, explanations of all the analytical methods, all the instrument methods, instrument instrument methods, and their standard procedures. Standard procedures, and validate against the sampling methods, we see precision standards across all sources. For example, also compare how some electrochemical methods described in the sources are related to any instrument methods discussed. Some errors. All right. So this goes from the first lecture, then the second lecture, then to the third. Initiating comprehensive analysis. I am not diving into blah 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 blah. So it's gonna get done with that. So recently on the previous search, on the deep research on the closely related sources that are tuned to this document, it had for the deep research the entire net or for the three sources and distilled out many, and out of the many it went through 43 sources. So I'm going to import all these 48 sources. So it's still uploading the sources. All right, when it's done uploading, there's a new feature called the data table. So what the data table does is that it tries its best to put you in a tabular format or in a relational format, the key metrics of all the entire sources. It could be, the standards that we use and their values in those sources. It could be the units used in that sources, what they are, the definitions and different sources. It could be, you know, um, some key types of instruments or key types of methods, or some key, modes that are very, very, key that everybody understands, right? So let me check the video I was generating if it's done generating with on my phone. So okay, so this is done. Instruments Instrumental methods of analysis rely on measuring the physical properties of analytes, such as the interaction with electromagnetic radiation, partitioning between phases, or electrical characteristics to perform qualitative and quantitative determinations. So here's a comparison of their theoretical explanation validated against the sampling and precision standards, and as well as how electrochemical methods intersect with these instrumental techniques. So it went from, it reset all the sources as can see this document 5, document 9, document 10, 11, 8, document 2, 4, 16, 17, 24, 17, 31, 32, even up to 36, right? So, because some of these notes are temporary, right? If I think this note is important, I save it as a source so that when I come back next, I'm going to find it here. So it says, for the first one, it says theoretical explanation and standard procedures for instrumental methods. Chromatography, gas chromatography, high performance, the ion exchange method. The core principle is the separation of the mixture by distributing its components between a stationary phase and a moving phase. That's one of the core concepts of, chromatography. And then the spectroscopy, we have the AES, UVs, the nuclear magnetic resonance, the fluorimetry. So this technique determines how molecules or free atoms interact. So the atomic absorption spectroscopy measures light absorptions by free atoms in gaseous states, while the nuclear magnetic resonance uses magnetic fields and radio frequencies. And then it went all and all and all. And then colorimetry, these are electrochemical methods. These are also electrical methods, electrophoresis, all these are electrochemical methods, right? So it said, what are the specific advantages of colorimetry over voltammetry? We answered some of these things in examinations like this particular question itself. So I think this note is also very important for me to just follow. So this is how to actually, so this is actually the concept to, seek, responses from, all of these sources through the help of, all the sources you've been able to upload, right? It searches all through the documents and then it puts together a very fine response that correlates with all the resources you've uploaded together. So if you just actually come here, all our sources have been uploaded and you can go on and on and on. So we're actually going to carry out a live demo. If you recall from one of the pillars, we said we wanted to see how we could actually utilize um Claude for deep thinking, and then NotebookLM as a knowledge base, as a localized knowledge base that is, based on the sources you provided. So let me just expand this a bit. Okay, let me go back to my screen. I was sharing my NotebookLM on my phone. We're generating a quiz. Let us see how that quiz looks like. So I'm gonna come back to this again. This secure copy to recast my phone screen. I'm sure it's doing that. Okay, it's come up. All right then. So this is the quiz that's been generated. I'm just gonna click on it to see how it looks like. So if you're confident after your studies that you can actually answer some quiz before getting to an examinations, you can actually generate the quiz so it still loads. All right, so as you can see, this is the quiz here. It says, which of the following set consists exclusively a SI-based unit utilizing mechanics and thermodynamics. Okay, so what may this answer be? Anyone recall who can actually give us what this answer may actually be? Does anyone? So I know that this is not involved. Tesla. Is Tesla involved in mechanics and thermodynamics, and mass is involved, temperature is involved, kg is involved, Kelvin, mole. So who wants to give us a try or what the answer may actually be? The SI unit bases that I use in mechanics and thermodynamics. So if you don't know the answer, you can actually click on hint. So it said focus on the 7 fundamental units that cannot be broken down into simpler components. So we have fundamental units that cannot be broken down into the simple components. So if you focus on the first 7, it actually gives us an idea. Can mass be broken down into the simple components? I don't think. Can seconds be broken down? No. Can kilogram be broken down? And what are the standard fundamental quantities? Can Kelvin be broken down? Area, mole, CD? I don't think. This is a mode. Anyways, let me per meter square. Let me take a wild guess. I would go with let me go with this. Oh shit. Right answer. I wanted to go to the first one. Crazy. So it says this represents the 7 fundamental units defined by the international system of units, including the distance, time, mass, temperature. This is something very new. I've always known about I'm gonna screenshot this, by the way. Right. I've always known the fundamental quantities, but I think this is one of the first times I'm learning about the first, standard, temperature. What is the temperature? First standard quantities. This is interesting. Okay, let me click on the next. According to the Kepler's second law of planetary motion, what remains constant for a line joining the planets to the sun as it sweeps through space? I don't know much about the Kepler's law, but the area swept out in equal time interval describe the orbital period, the average distance from the sun, the linear velocity of all the planets joined. So according to Kepler's second law of planetary motions, what remains constant for a line joining the planet to the sun as it sweeps through the face? What remains constant? This is a tip. What remains constant for a line joining a planet to the sun as it sweeps through the space? I don't know. Let me go A. Oops, I'm right. This law, also known as the law of areas, states that the orbital speeds of a planet varies such as the radius vector. This is interesting. I mean, the studies is great, man. But then I have to read about the Kepler's laws of motion. I mean, I'm just learning about it. Anyways, let's continue to things that matter. I'll stop casting the screen. So, all right. So we'll start another, cloud session. Let's see how we can transition from NotebookLM to Cloud for deep thinking. Right. So we have a document. We have a couple of documents I will show us here. Let me go back to my NotebookLM and then start a new notebook on this particular demo so that we go from utilizing Claude as your librarian that helps you put together resources, organize them, synthesize them, and read on them, and then Claude for deeper thinking and poking the holes in some of the theories that exist. So I'm going to upload a couple of files So I'm going to come here. We'll have document one. I'm going to open it. Then I'm also going to add another source. On the recent one, document two, this. So it's opening. All right. So we've seen how the audio works, the study guide dealer, the note, the compounding effects, and then uncovering the blind spots. Like NotebookLM generates billion-sided answers. Yeah, we've seen that how you can actually pin the source, like I've told you. If you feel the answer that has been given to you makes sense, the compounding effect. So over a semester, a student will pin the best explanations. So some of these pins that you pin from different conversations you have is what actually makes NotebookLM the most for you here. So when you open NotebookLM or select a specific source, NotebookLM automatically generated suggested prompts like we've seen. So the value in this is that um, if NotebookLM suggests a question about the core concept and you can't immediately, answer it before clicking on it, you just instantly identify that particular gap in your knowledge that needs to be reviewing. So the particular demo we're actually starting with right now is a basic chemistry midterm walkthrough from raw materials to a fully agentic analysis. So in this document, this Chem 101 introductory chemistry, we'll be looking at the atomic structure, the periodic table, the chemical bonding, and basic stoichiometry. Now, mind you, this is not the science class, right? You could actually utilize the sources, be it you're a science student, be you being an accounting student, an engineering student, a history student, then actually use the sources best your interest. This is just a template to how you can actually go about all of this. And then the three documents that I've uploaded, the first document was a syllable snippet, right? It shows the topics, the lab components, and then the grading breakdown. Let me come in. Let me go to the documents. So let me go to that document. This document one. Let's see what document one looks like. So this document one, it shows you the course content, results of chemistry, does the lab components, single replacement reaction. Students will react with various metals with hydrochloric acid to practice measuring gas production and calculating the mole ratios. Right. Um, document two is just a slide. So document two lecture slide. Slide one talks about chemical bonding. Um, okay. The other slide. Okay, slide two talks about the reactivity series, and then the last one, which is um, this is it here, the raw data. Right. You have the sample ID. You have 5 samples, and here you have different metals. You have magnesium is a metal, so you have two different metals here, and this is the masses of those metals. 0.5 grams, the volume of hydrochloric acid which we're going to use, and then the volume of the gas that was involved, right? So that's what we're going to use for our demo, right? So I would upload this. Okay, I've already uploaded the materials. Okay, so let me go back to my screen to source copy again. So I show simultaneously on my phone screen. So I'm going to go back. I'm sure you guys can see my screen if it's coming up. Okay, it's coming up. All right, I'm going to expand on it. And then I'm going to click on charts. I'm going to go back. Okay, that particular node is still coming up. Okay, yeah, see it here. 3 sources. All right, so this is the empty anyway. So I'm gonna enter a prompt. So the same way I would copy this prompt here. It says, let me go back to it. Sorry, I'm gonna go back to it. To analyze some comment. I'm just click on this to get the text from it. So I'm gonna go back and enter this on my NotebookLM. These sources, right? It says analyze the uploaded okay, I named it something else. I'm just gonna say analyze the CSV file, write and execute the Python code that calculates the moles of hydrogen gas produced from each of the samples like I've shown us. At room at standard temperature and pressure, 24 liters per mole. After calculating, identify any statistical anomaly in the dataset. Cross-reference any anomalies with the lecture notes and the 2026 web source to provide an explanation. So, okay, so um, this web source, I'm coming. So I've not searched the web source. So so this is the web source here. And it's the first search. So let me see what that first search actually is. Let me come back to this before entering this prompt. So document 1, document 3. So this is the agentic. I'm coming. Let me access the web search. So I'm gonna go back to one of the standard materials that I had that I used to prepare for this class and read it. All right, so I think I noted this down somewhere. Okay. Command. All right, so this is the web source here. It says, so the source title is this. I'm going to copy this, right, and click on copy. Then I'm going to come back. So since I'm using the same, add a source, I'm going to click on this. I'm coming. It's a web search, sources from the web. So I'm going to paste this particular one here. So this is actually how to find, sources from the web search, even on your phone. You can see it practically. So, the sources are still loading. All right. So these are all the sources. I think it resonates with what I want. So I'm just going to actually click on import. So it's uploading the sources for me. All right. So since uploading the sources, I'm just going to go back here. I'm just going to back to my NotebookLM since all the sources have been uploaded. So, all right. The sources have been uploaded. They're not done though. Okay. They have uploaded successfully. So I'm actually just going to copy this for a while and then refresh this particular page. Okay, so all the sources have been uploaded. So I'm going to paste back that prompt. So NotebookLM has the capability now to actually run your analysis. So you may be given a task that involves you writing Python codes on your behalf. So you could just say, instead of you writing codes by yourself or doing some of these computations by yourself, because this RAG-based model, Gemini NotebookLM is powered by Gemini 3.5, which has the capability for solving complex tasks, right? So this will run the Python code for us to calculate the moles of H2 gas that was produced. And then it's actually going to cross-reference any anomalies in those lecture notes with other sources it can find online, right? So I'm actually going to click on this. So it's reading the full chapters, checking your files, processing materials, reading your full chapters. So I'm currently focused on defining the core problem here, analyzing the CSV file, and these are just progress reports on how things are going so far. Well, anyways, since it takes time, right? It takes time so all these things take time. So I'm actually going to build infographics about this particular chart here, and also a mind map, and then also a quiz and flashcards. So all these will be generating while we are talking about this. So I have hit a snag. So it is running the code, investigate anomaly. So it's already done with the code itself. So I have executed the Python code to process the data set. So this is the data set here, like I've shown us here, right? So let me read what it has, and then calculate the moles of H2 gas produced by converting the gas volume from milliliters to liters and dividing by room temperature, molar volume of 24 liters per mole. So here are the calculated moles of gas for each sample. Sample 1, magnesium, give us 0.02 moles for 480 mils. And then as you can see, the variations, right? So the statistical anomaly here is that it was able to identify that sample 4 is glaring statistical anomaly, while all samples had standard 0.5 um, grams in terms of weight, right? Metal, and then 50 mils of HCl. As you can see, 50 mils of HCl, standard measurement across all. Yet, sample 4 produced drastically less hydrogen. So where sample 4, this sample 4 produced drastically less hydrogen. As you can see, this is 0.0019. Compared to the other two magnesium sample 1 and 3, which is this sample 1 and 3. Explanation for the anomaly. Cross-referencing the lecture notes and the study and the 2026 web sources provides a clear chemical explanation for what went wrong with sample 4. So this is the expected chemical reaction here. The experimental error is that the 2026 AXE Philo web source notes that magnesium ribbon can become oxidized, forming a layer of magnesium oxide on its source. So this is called, there's a term called passivation, and this is actually what's happening here. So the resulting impact is that the oxide layer physically prevents magnesium from completely reacting with hydrochloric acid, right? So I think this note makes sense. So if I really, so Gemini has just given me a context of what actually happened, but then I really want to understand the theory about this. So I'm going to save this to my notes. That it's actually going to save the notes anyway. Then I'm going to type, okay, give me a holistic summary for a handoff to Claude for deep theoretical um for deep theoretical, learning and experience. So this will generate a very deep holistic summary covering everything so far. I'm going to click on this charts. So I am now zeroing on the core objective, setting up everything. And then these are some of the flashcards while this continues and generates us a brief summary that we're going to hand off to Claude. Chemical equations for the reaction between magnesium and hydrochloric acid. What's the answer? So this is the complete chemical equation. All right, so this has given us the complete summary to hand off to Claude. Suggested handoff prompts. You can copy and paste the following text for your next phase of learning. All right then. All right, so I can actually copy everything here. Copy to clipboard. Then I go to Claude. New charts. New charts. Click on projects. Then click on iResearch. Then click on this now. Right. So there's a note about this. So you guys will recall earlier I mentioned that AI should actually serve as a tool. So this was the prompt that I used on Gemini. And then now on Claude, I could say, okay, this is about the flashcard and the quiz like we've seen actually. Right. So you can actually generate a video. We'll go to the video section very soon. You can actually export those videos offline. So Claude for deeper insight. So if NotebookLM is your librarian, which organizes your thoughts, your syllables, processing your lab data, fetching exact codes, think of Claude as your Socratic tutor. Is where the heavy lifting of thinking is actually done for you. But the biggest trap is for you to ask Claude or these AI tools to give you direct answers. You can actually do that by yourself in terms of putting these chat models as the co-pilots, right? Claude's real power is its ability to guide you through your discovery process without simply handing you the solution. And the framework is it's saying act as your creative tutor. Do not give me the answer. Ask me leading questions one by one to help me solve this problem. So I'm going to copy this framework. So this is framework that can be used as an instructions, right? As the base instruction or as base framework instruction for Claude moving forward on a particular chart. I'm going to go back here and then paste this framework. I'm going to give an instruction, use this framework or use this instruction, always this chart, right? Help me understand, understand the theory behind what's happening here, what's happening with the data, with the data. All right, I've already given an instruction. So it's, well, let's just wait for his response, see what it actually gives us back. All right, so let's start with magnesium anomaly. Since that's the actual data point you are trying to explain, sample 4 gave you 45 mils of hydrogen gas instead of 480 mils that are expected from the similar magnesium samples. Before we get to why, let us pin down what kind of problem this is. Question 1 now to me. If the unclean magnesium ribbon has a layer of magnesium oxide on its surface, do you think that HCl reacts with magnesium at all? Or if it does, would that reaction also produce hydrogen gas or something else? Think about the general form of acid reacting with metal oxide as opposed to acid reacting with free metal, and tell me what the product you'd expect. Do I really get what's happening here? All I know is that oxidation happens, right? With let me just write this, magnesium with the Mg ribbon, which why am I typing slow today? I'm so crazy. The ribbon, magnesium ribbon, which, oh my god, which in turn makes a reaction to not go to completion. That's why we have less gas liberated for sample 4, which makes the reaction to not go to completion. Is it right English? That's what I think. That's what I think. All right, so thinking about magnesium ribbon oxidation reactions and completion factors. Okay, so I'm thinking that the oxide layer causes incomplete reaction. Let's test that idea against what actually happens chemically. Question 2. Magnesium oxide is a basic metal oxide. When a basic metal oxide meets strong acid like hydrogen chloride, what type of reaction is that? And what products would you expect? Would hydrogen gas be one of them? So try writing out what you think the reaction between. So if I have my pen here, or this can actually be a test. So you have Mg oxide, you have a metal and a non-metal plus or minus plus HCl. HCl is non-metal hydrogen gas. So what would the reaction be? So you have magnesium chloride, so you have Mg chloride. I'm just trying to write some of these things out in my hand, and then you have HO. Then you have OH. So the reaction look like you would have. So I just wrote something down. I just wrote the chemical reaction and balanced it. So let me write down what I have here. Let me see if it's correct. So the products of this reaction every reaction is is what I got MGCL plus OH. Got this. Thinking about the balancing chemical equation with oxygen chloride and OH products. Good attempt. You're on the right track. This is an acid-base reaction, not a single replacement one, but let's check the formulas piece by piece. Question 2 says, what is the charge on magnesium when it forms compounds like MgO and magnesium chloride? Oh, all right. Thank you for that. So this is it. Claude, based on the instructions I've given Claude here, it will never give you an answer. It's actually going to keep testing you to keep gauging you over and over and over and over. As you can see, it keeps asking you more questions and I keep making attempts, right? So that's what actually the right approach to using AI is for studies, and it actually helps you reinforce and bolster your understanding about a particular course. Right. All right. So in the meantime, let me do something very quick on this. Let me generate the video. Let me come back to the studio pane and then click on video. So there are 3 different formats to make a video. It actually makes me an explainer video, or a very short one, or a cinematic video, which is rich, massive experience that can unpack, breaks complex ideas. And then what should the video actually focus on? Lab safety essentials. So since we're talking about this particular video in this question, I'll focus more on the theory of chemical reactions and the anomaly from MG. Also help explain MG passivation. And then I'll generate the video. May take time. All right, so this is here. But then I think the other time I generated some infographics. So I'm going to click on the infographics and see what I have here. The chemistry of reactivity in magnesium. So this is the infographics about what's happening with the data we're having problems with. So as you can see here, precision in the lab measuring atomic mass. So these are the scrub ribbons. This is way too small, but then I hope you get. Oh, okay, I can actually zoom in. Impressive. So this is here, standard molar volume constant, which was 24 liters per mole, 24 mils per liter. Yeah, this is here. So this is the ribbon here that actually causes the passivation. This is here, the oxidation that happens. The scrub ribbon to remove oxide. Yeah, and then there's some really complex stuff happening here. So this is an infographic. So what's happening? So you can decide to come in, download this particular source material. Right? Click on here. I can just click on download, and then this goes on your local PC without me coming back here again. This is it. I'll actually open this source and have it here. Right. So this is what's happening here. So this is an infographic about everything that this particular question is trying to solve. So the video is still generating anyway, but then let's continue on. So this is actually how to utilize NotebookLM and then actually Claude itself for your thinking. So use this master framework on any assignment, any subject. It forces the AI to walk beside you instead of ahead of you. That's actually how to put AI as a co-pilot, right? By the pilot. So there are 3 examples on the next subject. Like I said, you can utilize it for science, like we've done with the Chem 101 lab demo. For humanities, if you're a history student or law student writing and major AC, you can feed Claude your open arguments, ask it to challenge your underlying assumptions, and demand evidence for your claims, especially lawyers. You can actually lawyers argue a lot. You guys can utilize some of these concepts. Also for business and economics, if you're an accounting or economics student analyzing equity valuation stocks and so much more, Claude, you could utilize Claude quizzes, infographics, and ask Claude to help you, do stuff on maybe trading volumes, thresholds, impact, high price assets, and so much more, right? So anybody, literally anyone, can utilize these sources to their best of their interest using some of these frameworks, and the more ones you come across during your own time, having experience with these tools personally, you can actually use these tools as well to test or for logic testing purposes. So instead of asking Claude to explain the concept to Claude in your own words, and then ask Claude to critique your idea. Like we saw what I was doing with Claude when it's asking me some questions. I had to write the equation down to balance these things down. So this is how things work, right? And then Claude features workspace called artifacts. So Claude may generate you documents. These documents are called artifacts. They can be images, they can be documents, they can be HTML sites. They can actually, access some of these artifacts as an actual bonus to some of the explanations that you get. And then you can actually say, on the live demo report, you say, I am prepping for my Kemono 1 meeting. Based on this lab report, I'm going to explain why I think the gas production dropped. I want you to play the devil's advocate. Ask me a question and then test my understanding. Right. So it was just like something similar that I've just done, right, on the anomaly with the data. Right. So this is how to poke holes in the theories and in the deep understanding of some of the things you don't get. So how do you go about learning some of these tools without losing learning? Because you just discover that some people utilize these tools, they've not understood anything, and they've learned nothing. They've outsourced their critical thinking and their cognitive struggles to these tools, and they end up wasting their time without benefiting nothing. So, accelerating your learning while ensuring you never outsource your critical thinking is the true mastery that you require. Now, on the concept, AI can generate many perfect summaries for you. It can write flawless essays. It can solve you very complex problems in like 3 5 seconds. But if you're walking into an arena that requires your actual, faculty of thinking, then that's where the real problem is. And if you've actually been deceiving yourself over time, then you discover that the real mood has not been in your interest. So the analogy is that as a student, using AI for your studies is like having a spotter at the gym. Those spotters are people who can tell you, yeah, you can keep going. You can keep going. Don't give up. Right? Maybe I'm pushing 50 pounds, press ups, or, some of these bars people pull up. Right? These spotters can actually, continue motivating you to move forward. Right? So a good spotter helps you push through the friction when the weight gets too heavy. But if the spotter just lifts off the bars of your chest, your muscles will not grow. So what these spotters will actually do is that they are just very close by you to notice and to just guide you and continue motivating you. But if anything bad wants to happen at the diamond, that's when they step in. But if they actually, continue, helping you all through when these weights get heavy, those muscles that are going to the gym to, get will actually grow. Right. So cognitive struggle is real. Cognitive struggle is the friction of you trying to understand why an answer is correct. Is the actual mechanism that builds mastery. So I think cognitive struggle is something that we should struggle to continue building. In the age of AI, AI is here to stay, but don't lose the learning. Struggle and battle the learning effort for yourself, right? So I mentioned earlier about the blank sheet protocol. So the blank sheet protocol is that after utilizing AI for your course studies and everything, you get a blank sheet and put yourself to a test and say, can I rewrite everything that I've studied so far? So the action is that after spending 30 minutes sparring with Claude or reviewing NotebookLM flashcards, close the laptop, take a blank sheet of physical paper, try to write down the core concept, the mechanism, or the argument entirely from your memory. The reality check is that if you can't, without checking the AI back again, then the AI holds knowledge, not you in this case. So you've been able to derive answers from first principles and not just recognize the correct knowledge that appeared on the screen. That's what you've done. So this blank sheet protocol, something that you actually do. There's something Ben would normally say. Ben, can you hear me? There's something you normally call retentive or retaining knowledge. There's a word you put it. Can you unmute your mic and clear me out on that, please? You still around? Ben, can you hear me? Okay, maybe
Yeah,
he
yeah, yeah, I can
has.
hear you. I can
Okay,
hear you.
okay, okay, okay. All right. So there's this particular word you normally use when talking about how to read and retain knowledge. There's a particular there's a particular phrase you use. What is it again?
Yeah, yeah, yeah. I normally I think it's is it active recall.
Yeah,
Active recall.
active. No,
Can
I
recall,
think
right?
aside active recall, is something else again. There's another phrase you use for that.
I think I can't record that right now. If I'll do that before the call ends, I will let you know.
All right then, all right then. But actually, I can actually bank on active recall. So you can actually utilize active recall here, right? So after reading, after utilizing the sources, active recall is, I think, in its perspective, it means how much more can I, recall back everything that I've read so far. So this blank sheet protocol would help you realistically evaluate yourself before getting to the examination hall. It's something that deceives many people. You have been reading the course material for 6 days, you don't get it. But somehow, some people believe that magic will happen, that if I get into the examination hall, everything suddenly pulls back. How is that possible? It's not witchery, right? So, being honest about everything you do is the best way to move forward, and it helps you evaluate yourself. So, there's something called the Feynman technique, and it says if you cannot explain the concept to a 5-year old, you don't understand the idea. So, the best way to prove that you have not lost your learning is to teach it. That's why it says you must explain your idea to a 5-year old, and the 5-year old must understand. If a 5-year old cannot understand your idea, you don't actually understand what you're trying to teach or what you've been learning. So I'm going to teach you. So you could actually open a fresh chat on X or yeah, a new chat on Cloud and say, I'm going to teach you concept this. Act as a beginner who knows nothing about this topic. When I am done, grade my explanation out of 10 for clarity and accuracy and tell me what I missed. You can actually use this particular prompt always whenever you're trying to explain or whenever you're learning a particular concept and you want to, okay, not use AI as a co-pilot or use AI as a validator of knowledge. You can actually use this prompt. So whether you explain the cause, um, the Nigerian Civil War is something that people have been discussing over time, right? That is for history students, people in government, political science, and all. Or maybe the principles of titration, like we've been running so far all through the semester in the lab, or even forcing yourself to articulate the concept simply and clearly is the ultimate test of true mastery knowledge. So that's what the Feynman technique is all about. You can actually use that to validate yourself. So, all right, before I take my final review and then questions and then we call it a day, let's go back to the video we're generating. Oh, still generating the video. That's interesting. Wow. All right, let's continue class. Hopefully the video generates itself, gets done generating before the end of the day. So for those who joined us late, we talked about realistic expositions, talked about the myth, talked about the misconceptions people have about AI. We talked about the wider coverage, and we actually saw the numbers, how people are using AI, and some rankings on where and how they're actually using it, and the numbers. And then we saw how to use the notebook LLM to organize your notes, to add sources, to query sources, to generate flashcards, quizzes, infographics, and then we actually use Claude to really test the logic of some of the things that NotebookLM has been able to, put us and organize us. And then we saw what it means to get committed to allowing Claude do the heavy lifting for you, right? Claude helps you do the heavy lifting with some thinking that is bringing it much closer to you, but not being off the grid. So AI will make you faster, but only you can make yourself smarter. Use these tools to supercharge your preparations, but never let them do the thinking. Thank you very much. Well, anyways, questions and answers will come in. Meanwhile, I'll keep an eye on our video as it's still generating itself. So yeah, thank you very much. If you have any questions, this is the time to mute and speak.
Okay, Hendrix, thank you so much for this wonderful session. It has been I mean a long one, but I myself have learned a lot. I have seen you play around with you know a lot of things on Gemini Notebook, previously Notebook LLM, that I myself have never done before. I've never touched before, and to tell you the truth, I have learned a lot about all you've done today. It has been a very good one. I think we are here just with Hajara. Hajara have been on the call with us since then. I don't know if she have any question. Hajara, you've been on the call with us since then. I don't know. Do you have any question?
Hi, good evening.
Yes. Good evening.
Thank you so much. I have no question, but you have really learned a lot today. Thank you.
Okay. You're welcome. You're welcome.
Okay, Ben. So I don't know. Let me just play one of these videos on passivation. That's
Okay.
the concept that caused the anomaly in some of the data we looked at. That's one of the reason that caused the anomaly in some of the data we looked at earlier, right? So I don't know if you can hear this video. Let me play it.
Okay. We can't really hear the sound, but I can see it playing. I don't know if you can increase your volume.
Okay, I'm coming. Let me play it from the phone here. All right, let me go back here to this. Okay, the phone is dead. So let me bring it back on again. So let me just play the thing. This okay, I think this is it here. Sources, going to studio. All right, so this is it here. Let me play it so that we hear it and see it live.
Magnesium ignition is an atmospheric eruption, a flare of brilliant white light that reaches thousands of degrees in a matter of seconds. Despite that power, a spool of magnesium ribbon usually sits exposed on a laboratory workbench, appearing as nothing more than a dull, harmless strip of gray metal. It remains stable. This stability is due to passivation. When raw magnesium meets air, the surface oxidizes, forming a rigid crust of magnesium oxide. This barrier separates the metal from its environment. Oxygen molecules cannot reach the reactive atoms beneath, deflecting off the oxide shell. The reactivity of the element is effectively contained. Utilizing its chemical potential requires the intentional physical removal of that exterior armor. This process starts with a manual preparation step. Before ignition, a chemist must sand the ribbon, stripping away the dull oxide coating to reveal the raw, shiny metal underneath. Once that passivation layer is removed, the pure metal is vulnerable. However, it still needs an intense external heat source to trigger combustion. The Bunsen burner provides this activation energy. A focused light blue flame applied to the end of the sanded ribbon provides the heat necessary to kickstart the reaction. At this point, pure magnesium binds with oxygen to form magnesium oxide, resulting in a violent release of energy. The energy density is extreme. This chart shows its heat of formation emits 601 kilojoules per mole, far exceeding common reactions. Beyond the heat, the reaction emits 10% of its total energy as pure light. It is intense enough to cause immediate vision damage to anyone looking directly at the flame. Removing the passivation layer transforms a stable material into an immediate sensory hazard, unleashing energy levels that threaten human safety. Fire is only one manifestation of this volatility. A similarly aggressive interaction occurs when pure magnesium is submerged in dilute hydrochloric acid. This is
Oh yeah, so that was the video. I guess the video also reinforces our learning, and I hope that we have benefited from this class in ways that I don't know, I cannot explain or you cannot explain. But then you can still find this video back on our YouTube channel, I Read I Research. So yeah, thank you very much everyone. So I'm done.
Right. So, Hendrik, thank you very much. Thank you very much. Thank you very much. Thank you very much. We are grateful for taking out your time to prepare this wonderful session. It has been a long one, but then I'm telling you, it's worth it. And all we have to say is thank you, thank you, thank you, and thank you. All right.
Yeah, thank you very much, Dr. Man.
And then took out their time to be here. Thank you, Hajara. Thank you, Grace Joshua. Thank you for attending. And then yes, next week Friday, next week Friday we'll be having another session still on something very close to this that has to do with exams preparation. We'll be talking on how to use past questions to prepare for exams, and then how to study very well to ease your courses. It will be very, very good. I urge everyone that is here on this call, if you're going to be writing exams in the next 2, 3 weeks or 1 month, then I believe that class will be beneficial to you as well.
All right, so I missed any more contributions. I guess we call it a day. Thank you everybody for joining. Have a very wonderful night. Good night.